So now we are going to see the case number 2 of the types of conjugation, where the next conjugation is a double bond is conjugation with the negative charge, or you can say, or a double bond is in conjugation with lone pair. Both are same. This is called the lone pair. Why they both are same? They both are same because whenever you break like we have C H H H and H, whenever you break a bond, the hydrogen gives two electrons to that and it form HCH. And just take an example, negative and H positive. So negative means there is a lone pair. It is similar to case like ammonia, which is having an electron pair. So they both are quite a similar case, but here there is a negative charge because total charge was 0. Now there is a positive charge, but here due to neutralization it is like this, and here there is no charge, so it is a neutral molecule. So now is this a conjugation? What is a conjugation? All the p orbitals are parallel to each other. Here also p orbitals, two p orbitals are parallel. Now orbital is having a lone pair. Now here also two orbitals are parallel and one orbital is having a lone pair. Over here is a negative charge with lone pair. So now yes, these both are conjugation. Here what will happen in this conjugation? First there is a movement of the lone pair. There will be a movement of lone pair, not the double bond. So this lone pair will shift and here will shift. We have seen the previous case. We have seen that positive charge means there is no electron, so nothing will not move. Right? If there is nothing, how it will move? The movement is only of the electrons. So this will move and it will form double bond, and here will between the lone pair. And you can say if it goes there, positive charge and negative charge. And here also when this form goes here and this goes here, so it form and double bond and negative charge will come over here. So that's how there is a conjugation in between them. Now let's understand with an example. CH2 double bond CH2 negative, and it will form negative charge will go here, it will go here, CH2 negative, then CH double bond CH2. And how could be the resonance hybrid look like? CH2 CH2 here, partial double bond, delta negative and delta negative. Delta negative is negative of 1 by 2. Now there are a lot of cases, like we have seen the example, like if I write you like this, write the resonating structure of this, write the resonating structure of this, write the resonating structure of CH2 CH CH2 CH negative, CH2 negative. Write the resonating structure of CH2 negative, and write the resonating structure of negative. So you have to write all the resonating structure. This negative will go here and it will go here. So it will form negative over here. It will go here, it will go here. So it will form negative over here. So resonating hybrid will look like partial double bond, partial double delta negative, and delta negative. It will go over here and it will go over here. Negative. So how resonance hybrid will look like? Delta negative, delta negative. Here delta negative it means minus 1 by 3. Here delta negative means minus 1 by 2 charge. How partial? It is negative 1 by 2. But here there is no conjugation, right? Here it has come p and p orbital. So there is a breaking of conjugation. So it is not a conjugated system. But here in this case, it will go here, it will go here. And remember that whenever we are trying to move the negative charge, first of all, it will go in similar direction. We can't do like that it will go in this direction and it will go in this direction. Once we have started moving the direction, it will keep on moving in the same direction. This is important. When we started moving, it will keep on going in the same direction. Now it will form double bond CH2 and negative charge. So how overall resonance hybrid will look like? CH2 delta negative, delta negative. So delta negative is actually minus 1 by 2. Here it will go like this, negative and negative. It will go like this, negative and double bond. How the overall resonating structure will look like? Delta negative, delta negative. Wait. delta negative, and delta negative. That's how it look like. And delta negative is minus 1 by 3. And let's take some other examples. And as I have told you, there must not necessarily be a negative charge. There could be a lone pair also. Let's see some examples regarding the lone pair when it is present. CH2 double bond CH and O negative. CH2 double bond CH and OH. CH2 double bond CH and Cl free radical. N H and H. So it will go here, it will go here. So it will form CH2 negative CH double bond O. It will having a lone pair, it will go here, it will go here. CH2 negative CH double bond OH positive. It will go here, it will go. And as I always tell you, whenever I write the question, you have to try to answer by your own. First, then look at the answer. That will be the maximum beneficial you will get by these videos. So it will N double bond N H H positive, and it will get a negative charge. Or now you can draw the resonance hybrid by your own. In case of neutron, let me show you by one of the structures, CH2 CHOH, delta positive and delta negative. Now you can't write the delta positive and delta negative. Obviously, delta negative and delta positive has to be 1 by 3, 1 by 2, sorry, because on the two carbon atom there is a one charge and there are two carbon atoms. So on each and every carbon atom there is a negative 1 by 2 charge. So that's how you can write the resonating structure as well. I'm going a little bit pacely because we have draw a lot of resonating structure, and it must be your practice while doing that. I'm just instead of giving you just answer, I'm explaining with it, and after doing a lot of practice in this videos, we're gonna do that much practice that you will be just able to see the question and try to answer it by your own, even without putting a pen on the paper sometimes. And so finally aim to enhance your skills and speed. So first I'm going to write some resonating structure, then I'll give you time. Second, third, fourth, so double bond, it will go here, it will go here. CH3 negative, it will go here, it will go here. So actually it is not directly connected. So that's how it will look like. Now here also it will go on this side, positive. 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 Now when we have a lone pair, it will go in this side, OH positive. So how many resonating structure do we have over here? Here we have 1, 2, 3, 4, 5 resonating structure. And how the resonance hybrid will look like? This is a partial double bond, delta positive, delta positive, delta positive, and delta positive. So delta positive values plus 1 by 4. Right? Because we have 4 times delta positive over here, and the value is plus 1 by 4. Now because there is a overall positive 1 charge, and the 4 position are 1, 2, 3, 4 position are over here. Right? Now it will go like this, and it will form a positive negative charge. It will go like this. You might be wondering that why we are not going again backwards. This is also possible resonance. A negative charge in conjugation with double bond. So why we are going again back of negative charge? Because I have told you, when we start drawing the resonance into the direction, it will keep on moving in that direction. So it has to be unidirectional only. This is a rule of resonance also. So it negative double bond O H positive. It is going here. It is going here. Double and O H. NH2 same case. It will form negative. It will go on negative. It will go over here. So that's how the structure will look like this. Now let's draw 2 and 3 more structure to understand this particular case more. Like we have a question. Here is a negative charge, and one more question we have over here. Here is negative charge. So whenever here it is negative charge, one time resonance will go in that direction, and one resonance will be going in this direction. So here it is A and it is B, so it will be A structure by resonance, it will be B structure by resonance. Now whenever it is moving, it will go here and negative charge will come over here. It is moving. It is moving. And it is moving. And it is moving. So how many RS will be there? 1, 2, 3, 4, 5. 5 resonating structure will be there, and it will form delta negative, delta negative, delta negative, delta negative. So delta negative must be minus 1 by 5. So that's how we draw some of the cases of resonating structure with the conjugation with or negative charge is in conjugation with C double bond C. So we could write it as it is a negative charge or lone pair is in conjugation with C double bond C.